using high bit rates. They're not using the GSM. The people who are using the low bit rates are even bigger than this. These are the people that are having terminals that use extreme high bit rates. 1 billion people. That makes the companies accelerate the development and accelerate the deployment of these services, because they are after where the money is. Okay? And of course, this is good for us as engineers. We work on these systems, and we get courses, we get papers, we get patents. So both parties benefit. If you look at the future system, they have 3 main technologies common. What made high bit rates available now, and 20 years or 10 years ago they were not available? There must be some key thing. By the way, most of the tricks are known in the 60s and 50s, but they were very difficult to implement. They became very easy to implement when the CPU became very powerful. No, transistor هذا شيء قديم كثير. I'm talking about the CPU, the power of processing. When the power of processing became very cheap, you can get lots of power for very little cost, then these advanced systems became a reality. Look at the technologies. The first one is called multi-input, multi-output systems. So we will equip the receiver and the transmitter with multiple antennas. Previously, they used to have 1 and 1, so they talk to each other. Now we have multiple here and multiple there. And we have all sorts of interferences and tadakhulat between the signals. You need lots of processing, but there is a huge advantage. You can get lots of bit rates out of this process, but you need huge processing. So if the processing is cheap, use this technique. And now processing is becoming very cheap. My mobile phone here has a processor which is much stronger than the PC 10 years ago. So that's why it's usable now. So this is the first technology. The second technology is called OFDM. Rather than using the entire bandwidth, we divide the bandwidth into small chunks. And we send the data on every little chunk. And that's called OFDM. And all the new systems are using this. It is easy, it's doable, but it requires processing. So now we have strong CPUs, very powerful ones. So they are able to do this. The last one, which you will probably like this, computer engineering students, is something called software-defined radio. When we talk about these, كم system شفتوا بالجدول? Lots of systems, right? Now imagine building a mobile which is going to understand all these systems. The best alternative is to build a mobile which can program itself with the system that it finds. So it's not a mobile built for one specific system. It's a mobile that changes identity. It's called the software-defined radio. And this is now very hot in the technology. How do you do this? How could a mobile change its identity? Well, it has embedded systems in it. There are RAMs, memories, and processors. You load the program and execute it. So there are many embedded systems in the mobile. When embedded systems became available and very usable and very cheap, software radio became reality. And now we can build complex systems and complex networks with a huge amount of data. So these are the 3 main technologies that are made the systems advance to what we see now. Now let's talk about a little bit about the systems. What, 12:30? 12:30? Right. This is the system. Everybody knows GSM because we have GSM phones. We have UMTS phones. We can do on UMTS phone you can do voice as usual. And if you are courageous enough, you can do a little bit of video conferencing. That's why your mobiles have cameras on both sides, so you can do video conferencing. But the bit rates are what? What's the maximum bit rate? That's it. 2 megabits per second. They'll claim that you can get 7.2 if you buy their USB modem connect. But all these are still 3G. Okay, 3G. Now let's talk about this 3.75G. This is the system that is being tested now. It's called long-term evolution. The standard was only 1 year ago was completed, the standard. 2 weeks after the standard has been completed, the first system started operating in Sweden. So what does that tell? Tells you they are working actually, the companies who build the systems, they are just 1 week behind the standard document. Once the standard document finishes, the system is completely up and running. They need this. So in 2 weeks, it was done in Sweden and it was running. The system provides 100 megabit per second on the downlink and 50 megabit second on the uplink, which is a huge amount compared to what we deal with. If you look at the system, it uses MIMO, as I said, uses ODM, as I said, to be able to arrive to this huge amount of bit rates. It has good support for mobility, so you can drive your car with 500 kilometers per hour and you still good amount of data. Okay? I don't suggest that you do that, but this is what the system will give you. And it supports an all-IP core network. These systems from now on, the core network doesn't use proprietary protocols and odd things. No, everything is IP. They become very close to the internet that we use. Okay? So everything is IP based from the back. If you look at, so this is an LTE. If you look at the mobile, I don't know if the mobile, this is a Samsung mobile. It's called Touch 21. It supports LTE, so it can do 100 megabits per second and 50 megabits per second. And this was released very recently. And this one, the other one is the USB modem for 4G. If you look at the players, who owns what? The companies. We know the companies, right? Everybody hears about Alcatel-Lucent and Nokia, Siemens, Ericsson. And notice this, Huawei is huge company. But no, it wasn't like this 5 years ago. 5 years ago, it wasn't like this. In the news now, you go and search for Huawei, it's getting most of the contracts. Well, maybe they are cheap, but if they are not providing the same quality of equipment, they will not get the contracts. In business, it doesn't matter. In business, it matters when you get the contract. That's it.
For the long run, comparing all with others.
The revenue sheet at the end is what decides the stock value to go up or down, right? And it seems that they're winning. It seems they are winning. 36% of the contracts worldwide of LTE, which is not yet fully functional, is owned by them, and more. That's why I put this man with his thinking, what are these guys doing? Now, this was 3.75G. We're not 4G yet. Now imagine what 4G will do. 4G will do 1 gigabit per second to my mobile. Now what will you do with 1 gig? 1 gigabit per second to your mobile and 500 megabit per second going from the mobile to the system. This is what 4G should do. The system for 4G is called LTE Advanced. The other one is called LTE. This one is called LTE Advanced. The standardization for this is not complete. They expect to complete it in 2012. So there are no systems. There are no terminals for this. But when in Japan in 2007 they did an experiment. They built an LTE Advanced system. And when they build the initial systems, by the way, you don't get a terminal which is neat like your phone, no. The terminal is a van, which has all the equipment lined up in the van. And then they make the call with a tower like this. And when they achieve the bit rates that they want, they call the experiment successful. And that's what happened in 2007. Is they did the first 4G trial, and they were able to get 5 gigabits per second on this system. 5 gigabits per second. Okay. By the way, these things make us think a lot about there is a lots of room for innovation.